right, moving on to classifying triangles as congruent and similar. So congruent triangles, that's really just a fancy way for saying identical. They have the same shape, in other words, they have the same three angles, and they have the same size. So here in this example, we've got triangle ABC, which is congruent with triangle DEF. So if you look at the denotations there, we're saying angle A is the same as D, B is the same as E because it has double lines, and then our triple lines, our angle C is the same as angle F. And if you look at the side length markings, it's also showing that this side length equals this side length. This one here equals this one, and the third ones are identical too. So those are congruent triangles. Similar triangles are triangles where the angles are the same, but they don't necessarily, they don't have to be the same size. So one can be kind of a scaled up version of the other. They'd still have the same angles, but the side lengths might be different. So for example, here, we've got triangle ABC. If you look at the notations of the angles there, you'll see it has the exact same three angles as triangle XYZ, but clearly the side lengths are different. Triangle XYZ is kind of a scaled up version of triangle ABC. One important thing to know about similar triangles is the corresponding sides will always have the same ratio. And so what I mean by that, corresponding side is going to be kind of like the matching side. So for example, in this example above, if we had side length AB, well, it would be corresponding. I won't say it's equal because it's not. AB is corresponding to XY. So it's kind of like the matching side length of the same triangle. Okay, so for example, here we've been given a triangle ABC where we know the side lengths, and we've been given a similar triangle PQR. Okay, and so these we need to assume are similar. So let's draw on the markings here to make that more obvious. Okay, so this first one is kind of a scaled up version of the second one. And we want to solve for missing side length B. Okay, we can do this several ways. So in the example here, they've said B over 6.4. So we're doing this over this is going to equal this over this. So B over 6.4 equals 6 over 8. And then we can solve for B by multiplying both sides by 6.4. In other words, we're going to bring that 6.4 up across the equal sign. And so we get B is 6 times 6.4 over 8, which is 4.8. And there's many ways to do it, not just one. I could also, well, I could do the opposite ratio. So I could say 6.4 over B equals 8 over 6. And this time I'm going to multiply both sides by B. The algebra gets a little bit trickier here. So often it's best to keep your unknown in the numerator. But if we do this, we get 6.4 equals 8 times B over 6. Now we can multiply both sides by 6. And we get 6 times 6.4 equals 8 times B. Divide both sides by 8. And hey, look, we're back where we were up here. So we end up with the same answer of B is 4.8. So there's often several ways you can set up these ratios, and that is totally okay.